When is a sentence correct? We usually think about its grammar, its spelling, but what if you could judge it with math? What if a sentence could actually be proven correct, just like an equation?
So, let's just dive right into that. Can a sentence be mathematically correct? It sounds a little out there, right? Well, we're about to explore a system of communication that claims the answer is a definite, resounding yes. It's called quantum grammar, and it basically says that language can be built with the exact same precision as a math problem.
All right, take a look at this sentence. I know, at first glance, it seems super repetitive, maybe like it doesn't even make sense. But according to the rules of quantum grammar, this sentence isn't just correct, it's perfectly structured and mathematically sound. So how on earth could that be true? Let's unpack this thing.
To even begin to wrap our heads around that sentence, we first have to learn the core logic of the system, and it all starts with this one foundational idea called the rule of congruence. And believe it or not, it's all built around just 4 key words.
And here they are. Meet the 4 fundamental connectors of the whole system: for, of, with, and by. You can think of them as the absolute bedrock, the glue that holds these so-called mathematical sentences together. But here's the catch. They don't just work randomly. They operate in very specific pairs.
And this is it. This is the entire rule. Right here, it's actually pretty simple. For is always paired with by, which means they're interchangeable. And of is always paired with. This simple pairing is the foundation for absolutely everything else. So just lock this in. For goes with by, and of goes with.
Okay, so how do these pairs actually work in practice? Let's circle back to that strange sentence from the beginning and really put this rule of congruence to the test. See, this system has a very unique way of proving if a sentence is legit. And here's the main event. This is the core test. A sentence is only considered correct if its meaning holds perfectly true when you read it forwards and backwards. But, and this is a big but, there's a very specific trick to reading it in reverse. It's not as simple as just saying the words in the opposite order.
This slide just breaks down the whole process for us. So, when you read the sentence backwards, you also have to swap the congruent pairs. That means the by at the very end becomes a for at the new beginning. The with becomes an of. And when you do this swap correctly, the sentence supposedly keeps its exact same meaning in both directions.
Now, let's add the next layer, because it just keeps building. To make writing all this a little more efficient, the system introduces a kind of shorthand, and it uses a punctuation mark we all know, the colon.
So instead of writing out for, of, with, and by every single time, you can just use a colon. Which brings up a good question. How can one little symbol possibly stand in for 4 different words? Well, it all comes down to where you put it in the sentence.
This table here lays it all out. A colon at the very beginning of a sentence, right up against that first word, stands for, and that represents the cause. If it's in the middle of a sentence, it actually signifies both with and of, which is called the concern. And a colon at the very end of everything stands for by, which is described as the authority. It's kind of like a secret code hidden in plain sight.
Okay, I know what you're probably thinking. This seems incredibly complex. We've got rules, special pairs, punctuation codes. So what is the ultimate goal here? Why would anyone go through all this trouble just to structure a sentence in such a specific way? Well, at its heart, the entire system is designed to achieve one thing: perfect clarity. The whole goal is to create a way of communicating where the structure is so rigid and so verifiable that the meaning becomes totally locked in place, unable to be twisted or misunderstood.
I mean, this quote from the source material really says it all. The entire point is to eliminate ambiguity completely. By building sentences that have to be correct forwards and backwards, the system claims that its meaning is secured from any kind of manipulation.
Maybe the best way to think about it is with this analogy. When you solve a math problem, right, you can often check your work by doing the reverse operation. Well, this system applies that exact same logic to language. Reading a sentence forwards and then backwards with a swap is like doing the problem and then checking your answer to make sure it's absolutely correct.
And all of this leaves us with a really fascinating final thought. This system proposes a pretty radical way of looking at language, not as this fluid, evolving art form, but as a precise, verifiable science. So what would our world actually look like if all communication had the same certainty as mathematics? What would we gain, and what might we lose?